Greeting and welcome all on behalf of NIMI, Chennai. I am G. Rajeshwarna from National Skill Training Institute, Chennai. Today our topic is standard and standardization. In India, BIS certification plays a major role in importing and exporting goods in local and international trades. So BIS certification gives so many advantages to manufacturer, to consumers, to organized purchasers and to exporters. Advantages of BIS ISI certification marks scheme. So the BIS gives more advantages to manufacturer. One, it is streamlining of production process and introduction of quality control system. And also independent audit of quality control system by BIS. And reaping of production economics occurring from standardization. Next is, it exposes better image of product in the market, both internal and overseas. Last one is easy of winning for wholesalers, retailers and stockist consumers, confidence and goodwills on the manufacturer. The performance for ISI marked products by organized purchasers, agencies of central and state governments, local bodies, public and private sector undertaking, etc. Some organized purchasers offer even higher price for ISI marked goods. It financial incentive offered by the industrial development. So Bank of India, IDBI and nationalized banks may lend help for the manufacturers. Next, the advantages to consumers. Conformity with Indian standards by an independent technical national organization. It helps in choosing a standard product. That means consumer can easily choose standard product. Free replacement of ISI marked products in case of their being found to be of standard quality. Next, protection from exploitation and deception. And also assurance of safety against hazards to life and property can be given to the consumer. Next, the advantages to organized purchasers. It is convenient basis for concluding contracts. The elimination of the need for inspection and testing of goods purchased, which saves time, labor and money to the purchaser. Free replacement of products with ISI mark is found to be substandard. The advantages to the exporters. The exemption from pre-shipment inspection wherever admissible. And the convenient basis for concluding export contracts. The advantages to export inspection authorities. It eliminates the need for exhaustive inspection of consignments exported from the country, which saves expenditure, time and labor. The benefits of standardization. Some overall benefits of standardizations are as follows. Improves quality because a standard process will eliminate the need for guesswork or extra searching. It guarantees quality because work is done in a predefined optimized way. So the guarantee is quality. Promotes productivity because employees will follow the standard processing for the production. So it promotes productivity. boost employee morale because employee can take pride in having mastered the process and refined the skills. Perfect customer service because every product is handled in the best possible way to come out. The first and most obvious benefit of standardization is that it decreases ambiguity and guesswork. Standardization guarantees quality. So, I hope now you know what is standard, what is standardizations, what are the organizations for standardizations and the benefits of standardization. Thank you all. See you in our next video.
Greetings. Welcome you all on behalf of NIMI, Chennai. I am Sivarasu from NSTA, Chennai. Today we are going to discuss about types of punches. Let us discuss with the why punching is important. After marking a line by using scriber, due to handling, the lines will be erased. The tool which is used to make the line permanent is called as punch. Punches are used in order to make certain dimensional features of the layout permanent. Now, we will see the parts of punches. Number 1, head. Number 2, body. Number 3, point. Now, let us see one by one. Number 1, head. It is the portion of the where you strike the hammer. Number 2, body or shank. It is where you place the finger to hold the punch. The body portion of the part is knurled for better gripping. Number 3, point. This portion of the part make the line permanent. Punches are generally about 100 mm to 150 mm length and the diameters are 4 mm to 12 mm. Punches are made of high carbon steel, hardened and ground to the point angle according to the operation. Now, we will discuss about the types of punches. Number 1, center punch. Number 2, dot punch. Number 3, prick punch. Number 1, center punch. The angle of the point is 90 degree in a center punch. The punch mark made by this wide and not very deep. This punch is used for locating center of the holes. The wide punch mark gives a good seating for starting the drill. Number 2, dot punch. This punch is similar to the center punch. The only difference is that it is a point angle 60 degree. The 60 degree punch is used for marking witness marks and called as a dot punch. The witness marks should not be too close to one another. Number 3, prick punch. The angle of the prick punch is 30 degree. The 30 degree point punch is used for making light punch marks and needed to position dividers. I hope you are all understand about the types of punches and their uses. Thank you. Good morning everybody, I am Sivarasu from NSTA Chennai. Today we are going to discuss about the types of vices. Last class we have already discussed about the bench vise, parts and their functions. Today we are going to discuss about types of vices. In engineering workshop, it is absolutely essential to hold a job strongly for the purpose of carry out the various operations in different positions. Generally, vices are used. For example, filing, drilling, chipping, axing, tapping. The different operations they are using vices. There are different types of vices are available. There are different types of vices used for holding the workpiece in different operation. What are the different types of vices? Number 1, quick releasing vice. Number 2, pipe vice. Number 3, hand vice. Number 4, pin vice. Number 5, tool maker's vice. Number 6, leg vice. These are the different types of vice. Let us see one by one. Number 1, quick releasing vice. A quick releasing vice is similar to an ordinary bench vice, but the opening of the movable jaw is done by using trigger. There is an additional lever is available in order to quick opening and closing. If the trigger at the front of the movable jaw is pressed, the nut disengages the screw and the movable jaw can be set in desired place quickly. This is the main advantage of quick releasing vice. We can open the vice or closing the vice very quickly. That is the purpose they will be using quick releasing vice. Number 2, pipe vice. Pipe vice has a V grooves of 90 degree for holding the round section of metals such as tubes and pipes. In this vice, the screw is vertical and movable jaw. The jaws works vertically. The pipe vice grips the work at 4 points on its surface. What are the major parts of pipe vice? Base, lower jaw, upper jaw, spindle, handle. So pipe vice mainly used for holding round section of metals, tubes and pipes, etc. In this pipe vice there are different parts. Now let us see the one by one. Base. A base which holds and support all the parts and has a 4 holes on base to clamp on the bench. The pipe vice clamping that, the base having the 4 holes in order which place required we can clamp on the bench. Lower jaw. This is the part is attached to the base in the fixed position. So in this base the fixed jaw, lower jaw is attached on it. Number 3, upper jaw. This is the part is attached to the spindle. When we rotating the handle attached to the spindle, upper jaw moves up and down. Number 4, spindle. The spindle moves the up and down according to the direction of rotation. Spindle moves according to it will move. Now you look at the diagram, different parts. So holding that there will be V shape of lower jaw, upper jaw is arranged. So a round section of metal we easily when clamp on this pipe vice. Another one is hand vice. Hand vice is used for gripping screws, rivets, keys, small kind of drills and other similar objects which are too small to be conveniently held in the bench vice. Hand vice is made up of various shapes and sizes. The length varies from 125 mm to 150 mm. The jaw width from 40 to 44 mm. The jaws can be opened and closed using the winglet on the screw that is fastened to one leg. Next one is pin vice. The pin vice used for holding small diameter of jobs. It consists of handle and small collar chuck at one end. There is a collar chuck at the one end. The chuck carries a set of jaws which is operated by turning the handle. Another one is tool maker's vice. The tool maker's vice is used for holding small work which requires a filing or drilling and for marking of small jobs on the surface. This vice is made of mild steel. The tool maker's vice are accurately machined. The last one, leg vice. A leg vice is holding device generally used in forge shop for bending and forging work. For a forging shop there are different operations they are using. That is the place they will mainly use for leg vice. It is made out of mild steel to avoid breakage while hammering or wrought iron material sometimes made out of. What are the major parts of leg vice? Number 1, solid jaw. Number 2, movable jaw. Number 3, threaded jaw. Number 4, spindle. Number 5, spring. Number 6, pivot. Number 7, leg. Number 8, clamp. Like that there are different parts of leg vice. Since the hinged jaw moves in a radial path, the job held in this vise is not gripped properly because of this line contact. Hence, the work which can be carried out on bench vise not held in the leg vise. So, jobs which carries hammering only are held in the leg vise. So, the leg vise mainly used in forgings for different operation. I hope you are all understood the types of vices and their applications. Thank you.
Arc welding. Type of weld: pipe butt weld. Type of joint: butt joint. Position: 1G horizontal position. Rolling. Material: MS pipe. Now we will go into the details of how the pipe welding can be done in 1G position. Ends of the pipe are beveled 30 to 35 degrees. A root space of 1.5 mm to 2 mm is maintained. After beveling, the edges are well ground and filed. All dirt are removed. The pipe have to be tack welded in 4 positions. After tack welding of the pipe, it is kept horizontally with the axis parallel to the welding table. Now you can start the welding with 3.15 mm electrode and the current setting of 100 to 110 amperes. Before you start the welding, you strike the arc on a separate plate to ensure that the arc is stable and uniform. The electrode makes an angle of 60 to 70 degrees with the line of welding, and it is 90 degrees with the plate surface. In this position, you can weld the pipe in the flat position by turning the pipe. After completion of the root run, the root is perfectly cleaned by deslagging with a chipping hammer and apply a wire brush for perfect cleaning. Once the cleaning is complete, you can have the first run and the second run. As for the root run, use 3.15 mm electrode with a current setting of 100 to 110 amperes. Once the welding is completed, clean the weld surface using a chipping hammer, wire brush it and inspect for any welding defects. The bead of the weld should be very uniform. Reinforcement should also be uniform. Arc welding. Type of weld, pipe butt weld. Type of joint, butt joint. Position, 2G vertical position. Material, MS pipe. Now we will go into the position of welding in the 2G position, that is the vertical position. The axis of the pipe is vertical and the edges of the pipe are prepared as you have done for the 1G position. The tack welding is also done. Each tack weld can end with a keyhole. The current setting is as recommended by the manufacturer of the electrode. In general, it is 100 to 110 amperes for 3.15 mm electrode. After tack welding, the pipes are kept on the welding table or at a correct height convenient for your welding. The welding is done in a horizontal position all around the pipe. If you want, you can turn the pipe also. After completion of the root run with 3.15 mm electrode, the root is cleaned perfectly by T-slagging and wire brushing. You can have the first run and second run using 3.15 mm electrode. Once you complete the welding, clean the welding by removing the slag and wire brush it and inspect the welding for any type of defects. Arc welding. Type of weld, groove weld. Position, 2G horizontal position. Material, MS plate. The preparation of the plate is same as you have done for 1G position. After preparing the plates are tack welded the same way as you have done for flat welding. A root gap can be normally provided. It should be 1.5 to 2 mm only. A distance piece can be used for this purpose before the tack weld is done. The plates are kept on the table in such a way the surfaces of the plates are vertical and the axis of the plate is horizontal. As in the earlier cases, you can use 3.15 mm electrode for tack welding as well as for the root run. The current setting is around 100 to 110 amperes and the welding is done from one end to the other end. After completion of the root run, the root is perfectly cleaned, all the slags removed by chipping hammer, then apply wire brush for perfectly cleaning the roots. This should be done before you have the first run and the second run. Having completed the cleaning, you can use the same 3.15 mm electrode for the first run and the second run. After the first run, you have to clean the surface, that is, the weld surface should be cleaned perfectly. At the end of each run, you have to close the crater. That is, as you have done, you have to start ahead of 20 mm and start slowly and close the crater perfectly. Once welding is completed, de-slag, clean the weld surface properly using a wire brush, and after that check for any defects. Arc welding. Type of weld, groove weld. Position, 3G vertical position. Material, MS plate. Next is a butt groove welding in the vertical position, that is 3G position. The preparation of the workpiece is the same way as in 1G and 2G position. After preparing the plates, tack welding is made as usual. A root cap can be normally provided. It should be 1.5 to 2 mm only. A distance piece can be used for this purpose before the tack weld is done. You can use 3.15 mm electrode for the root run. After the tack weld has been done, the plates are kept vertical to the surface of the table and the axis is also vertical. Set the current 100 to 110 amps. We check the arc by striking in a separate plate whether the setting is okay or not. Start welding from bottom to top, that is uphill position. One thing I have to remind you, when you are doing a vertical welding in an uphill position, that is starting from the bottom to the top, a slight change in the current will be required. Previously you have been welding in 100 to 110 amperes, but when you are doing a vertical welding, you may set the current at reduced amperage. It can be around 90 amperes. If you require, you reset the current and start the welding. Once you complete the welding, as you have done earlier, clean the root, de-slag completely, apply wire brush. Now you can have the first run. After the first run, close the crater again. Clean the welding surface by deslagging, wire brushing, and then have the second run. After completion of the second run, clean the surface of the welding by deslagging and wire brushing, and then check for any welding defects. Arc welding. Type of weld, groove weld. Position, 4G overhead position. Material, MS plate. Finally, we have to do the butt groove welding in 4G position, that is overhead position. Here the plates are kept parallel to the surface of the welding table in the above position. The axis is horizontal, you are making the welding from the bottom. The workpiece is prepared as we have done for the other examples. After preparation of the workpiece, they are tack welded using 3.15 mm electrode. The root gap can be narrowly provided. It should be 1.5 to 2 mm only. A distance piece can be used for this purpose before the tack weld is done. You can use 3.15 mm electrode for the root run. The workpiece is then properly held in the position so that you can conveniently weld from the bottom. Normally the required current setting is slightly less for the overhead welding, around 90 amperes instead of 100 to 110 amperes for 3.15 mm electrode. After setting the current properly, you start welding from one end to another, that is normally left to right. Once you complete it, close the crater. Take 20 mm ahead, then start back. Then chip off all the slags, apply wire brush and clean the root perfectly before the first run. Once the root run is completed, and have the first run and second run. Once the second run is completed, close the crater. Clean the surface perfectly and inspect for any welding defects. Arc welding. Type of weld, pipe butt weld. Type of joint, butt joint. Position, 1G horizontal position, rolling. Material, MS pipe. Now we will go into the details of how the pipe welding can be done in 1G position. Ends of the pipe are beveled 30 to 35 degrees. A root space of 1.5 mm to 2 mm is maintained. After beveling, the edges are well ground and filed. All dirt are removed. The pipe have to be tack welded in 4 positions. After tack welding of the pipe, it is kept horizontally with the axis parallel to the welding table. Now you can start the welding with 3.15 mm electrode and the current setting of 100 to 110 amperes. Before you start the welding, you strike the arc on a separate plate to ensure that the arc is stable and uniform. The electrode makes an angle of 60 to 70 degrees with the line of welding and it is 90 degrees with the plate surface. In this position, you can weld the pipe in the flat position by turning the pipe. After completion of the root run, the root is perfectly cleaned by deslagging with a chipping hammer and apply a wire brush for perfect cleaning. Once the cleaning is complete, you can have the first run and the second run. As for the root run, use 3.15 mm electrode with a current setting of 100 to 110 amperes. Once the welding is completed, clean the weld surface using a chipping hammer, wire brush it and inspect for any welding defects. The bead of the weld should be very uniform. Reinforcement should also be uniform. Arc welding. Type of weld, pipe butt weld. Type of joint, butt joint. Position, 5G horizontal position, fixed. Material, MS pipe. Here the pipe is horizontal but cannot be rotated. In 1G position, we have seen that the pipe can be turned and always the welding is done in the flat position. Whereas in this case, the pipe cannot be turned and the welder has to go around the pipe and weld. The welding can be done in different methods. One, in the downhill method. Assume that the circumference of the pipe is divided into 12 hours. You can start from 12 and come to 6 in the right hand position. Again, you can start from 12 and come to 6 in the left hand position. For the right hand position, you weld in the clockwise direction, and for the left hand position, you weld in the anti-clockwise position, both starting from 12. The second method is uphill position, in which you start welding from 6 and go to 12 in the anti-clockwise direction in the right half. Similarly, you start from 6 and go to 12 in the clockwise direction in the left half. The preparation of the pipe is similar to what has been explained in the other position. Then tack welding is done using 3.15 mm electrode. Four tacks are normally done after the pipe is kept in the horizontal position, so that you can go around without any difficulty. Once the root run is completed, clean the root perfectly using chipping hammer and apply a wire brush. Then have the first run and the second run. After each run, you have to clean the surface before the next run. After completion of the weld, clean the weld surface and inspect for any defects. Arc welding. Type of weld, pipe butt weld. Type of joint, butt joint. Position, 6G inclined position, fixed. Material, MS pipe. After beveling, the edges are well ground and filed. All dirt are removed. Then the tack welding is done. The tack welding will be ending with a keyhole. After the tack welding is completed, the pipe is fixed in such a way the axis of the pipe will be maintained at an angle of 45 to plus or minus 5 degrees and the pipe is fixed. You cannot rotate the pipe. The welder has to go around the pipe and weld. You can use 3.15 mm electrode for the root run with a current setting of 100 to 110 amperes. The method of welding is as I explained for the 5G position. Either the uphill position or the downhill position can be used. Once the root run is completed, clean the root using a chipping hammer and deslag it and apply a airbrush. Then have the second run and the third run. Once the welding is completed, clean the surface of the weld after each run by deslagging and wire brushing. At the end of the weld, inspect for any welding defects. So far we have done all the exercises in the manual arc welding. Now we will do the exercises in TIG welding. Arc welding. Type of weld: straight line bead. Position: 2G horizontal position. Material: MS plate. The plate will be kept with the surface of the plate perpendicular to the table and the axis is horizontal. You have to do the welding in the flat position as you have done earlier from left to right. Once you reach the extreme end, that is the finishing end, the crater has to be finished. So you take at least 20 mm ahead of this welding and again start back. Once you finish this welding, check the welding for correct bead height and correct bead width. After the horizontal welding, you can repeat this in the other two positions, vertical position as well as the overhead position, that is 4G. Arc welding. Type of weld: straight line bead. Position: 3G vertical position. Material: MS plate. Arc welding. Type of weld, straight line bead. Position, 4G overhead position. Material, MS plate. We have already learned how to run straight line beads on fat plates in all 4 positions. In this chapter, we will learn about butt welding for pipe butt joints using arc welding and TIG welding methods. Arc welding is a process by which a coated electrode is used to strike an arc between the electrode and the base metal. The heat generated in the arc is used to melt the base metal, and the electrode is melted and passed on to the weld pool as deposited metal. The gas generated while burning the electrode is used to protect the arc, and the slag formed on the welding pool used to protect the weld pool from the atmospheric air to avoid any contaminations.
નમસ્કાર. પ્રધાનમંત્રી કિસાન માનધન યોજના અંતર્ગત નાના અને સીમાંત ખેડૂતો માટે ભારત સરકારના કૃષિ એવં કિસાન